Alright, CNT125, Chapter 8. We're hitting the section where they're introducing subnets to us. First, if you take a look at a network like so, you have, 3 floors of a building. This is the picture that's in your book for you. You have 3 floors of a building, 1, 2, 3. All the devices on each floor are connected to a switch. All the switches are connected together. And all of those then are in turn connected to one router. So what you have here is, if you take a look, everything is in a kind of a layer 2 network. So all these nodes are connected to switches. Switches know where devices are. So in reality, a computer up here on the 3rd floor can communicate directly with a computer down here on the 1st floor. So the good part is they can communicate very easily with each other. The bad part is, as we talked about, some of our protocols broadcast by default. So when a computer up here on the third floor generates an ARP broadcast, for an example, that is going to go to all floors of the building throughout the entire building. So maybe not the most efficient design of a network because of that. And the book talked about in here, any host can communicate directly with another host. Absolutely. This one router serves as the entire this one router serves as the gateway for all the nodes in the whole network, and therefore everything in this network is all going to belong to the same IP pool, if you will, pool of IP addresses, all going to belong to 192.168.89 network. So there would be, maybe for a small network that's okay. As more nodes come onto the network or the network grows some more, this might not be adequate. So the book then talks about, okay, as the network grows, as more nodes come online or more traffic needs come online, a solution could be to literally create a subnet for each floor using a layer 3 solution, in this case routers. So in this design, they put a router on each floor. What that's going to do is it says, all right, if I install a router on each floor, the routers aren't going to forward broadcast traffic. Absolutely. So if a computer up here on the 3rd floor generates an ARP broadcast, which they're going to, that is going to stay local to this floor and will not propagate through the whole building because this router is going to stop that. That's going to help minimize the amount of traffic from here interfering with traffic down here and so forth. What this is also going to do is literally create a layer 3 subnet for each floor. This floor up here, this floor here, this floor here. So in this case, we might have a scenario where 192.168.10 network up here, 192.168.20 network here, 192.168.30 network here, or 10.20.30, however you want to do it. But the bottom line is there will need to be a unique pool of addresses for each floor, each subnet for each floor. That's going to help contain the traffic per floor and filter some of that broadcast traffic so it does not travel throughout the entire building. That'd be the good side of this. The bad side is adding a router on each floor. That adds some equipment cost. That also does add some processing cost, if you will, latency. Data moving from floor to floor has to go through 2 devices, get processed by 2 devices here. So they introduced the idea of, if you have a small network, a entire layer 2 switch network, okay. As it grows, you might need to implement something like this. There's various options, but something like this to account for the growth and doing some containment by broadcast demand on each floor. So subnetting is going to help us manage the IP address more efficiently, yep. And they also provide some other benefits to us. It also makes network documentation easier because I can literally say, okay, let me back up here real quick. 192.168.10 network is here, that's the 1st floor. 20 networks here, the 2nd floor. 30 network here is the 3rd floor. So I know kind of where everything's are, and that also is going to help with troubleshooting. If I know there's a problem coming from the 192.168.20 node, I know it's on the 2nd floor. Routers can more easily manage IP address spaces that don't overlap. Yes, the router works a little bit more efficiently if we know. Come back up here real quick. It knows that, hey, the 20 networks here and the 30 networks here. It's more organized. The router can process that a little bit easier. And again, as we're saying here, if we have it well planned out, routing is going to be more efficient. All right, we'll come back in the next one and talk subnet masks.